Okay, this is number 18, the real number 18. I had to redo it about a million times because people kept calling. Okay, so part A. So just ignore that one on the other video. The limit as h approaches 0 of f of 2 plus h, because I'm supposed to find the limit when x is 2, minus f of 2 all over h. So what this means, I'm going to take 2 plus h and plug it into all of my x's. Okay, so that's what I'm going to do first. The limit as h approaches 0, 2 plus h quantity cubed minus 3 times 2 plus h minus 8 minus, so I did this part, now I'm going to take f of 2, here's my f equation, and plug 2 in. 2 cubed minus 3 times 2 minus 8 all over h. So I have the limit as h approaches 0. This means 2 plus h times 2 plus h times 2 plus h minus, I'm going to go ahead and distribute my 3. That's 6 minus 3h minus 8 minus 8 minus 6 minus 8 all over h. Okay, so now I have the limit as h approaches 0. I have to FOIL this out. Okay, so when I FOIL all of this out, I'm going to do this first 2. I get 4 plus 4h plus h squared times 2 plus h okay, minus 6 minus 3h minus 8 minus 8 plus 6 plus 8. I distributed my negative all over h. Okay, so I'm going to keep on going. The limit as h approaches 0, now I'm going to multiply this out. When I multiply this out, 4 times 2, that gives me 8. 4 times h is 4h. Now I'm going to do my 4h. 4h times 2 is 8h. 4h times h is 4h squared. H squared times 2 is 2h squared. H squared times h is h to the third. Okay. Do you see that this 6 is going to cancel out with this 6? This negative 8 will cancel out with this positive 8. And I'm left with minus 3h minus 8 all over h. Okay? So let's see what will cancel. Do you see that this 8 will cancel with this 8? Is there anything else that will cancel? I don't see anything right now. So now I'm going to combine any like terms. So I'm going to write them in descending order. I'm going to write my h to the third first. So I have h to the third. I'm going to mark it out as I go. I'm going to combine my h squared. So that's plus 6h squared. I'll mark those out. I have a 4h and an 8h. That's 12h minus 3h. So that's 9h all over h. Factor out an h on the top, and I'd have h squared plus 6h plus 9 all over h. My h's will cancel, and now when I find the limit as h approaches 0, I can use direct substitution, and I get 9 as my answer. Okay, so that's for part A. Part B said, find an equation of the tangent to y equals f of x at x equals 2. So I know my slope. My slope is 9. I know my point. The point that they gave me in part B was when x is 2. So I know I have the point 2, but I don't know what my y value is. I can find out my y value by plugging 2 into the original equation. So when I plug 2 in, I get 2 cubed minus 3 times 2 minus 8. So that's 8 minus 6 minus 8. So I get negative 6. So I have the ordered pair 2, negative 6. Then I'm going to plug that into my point slope form. So I'd get y minus a negative 6, so y plus 6 equals 9x minus 2. So that is your number 18. 19. For the function whose graph is shown to the left, accurately sketch the derivative y equals f prime of x on the grid to the right. Label your axes. Mark clearly the places where the graph crosses the horizontal axis. Okay, so he should have taught you that anywhere I have a maximum or a minimum on my original graph, that's where it crosses the x-axis. Okay, so I know if this is my x-axis, and I'm going to say this is 1, 2, 3. 1, 2, 3. I know I have a maximum when x is 0. So I know this is going to cross the x-axis at 0. I have a minimum when x is 1.5. So it's also going to cross at 1.5. And I have a maximum again when x is 3. So I know it's going to cross at these 3 points. Anywhere you have a maximum in, that's where it crosses the x-axis. I also have a max. The derivative has to go from positive to negative, or above the x-axis to below the x-axis. So I know since I have a max here, it has to go from above the x-axis to below it. When I have a min, my derivative goes from negative to positive. So I know my graph has to look something like this. Okay, it has to pass these points and it has to go from positive to negative because I have a maximum there. Then somewhere it's going to go back up because it's going to go from negative to positive and from positive to negative again. So we don't know exactly what it looks like, but it's going to look something like that. Okay, it crosses where you have maxes and mins, has to go from above to below where you have a max, from below to above when you have a min. Number 20, suppose the graph of x is shown. Indicate which of the graphs below is the graph of the derivative. So I always find my maximum and my minimum because those are the places where it's going to cross the x-axis. So I know at 0 or a little before 0, it should be crossing the x-axis on my derivative because I have a max there. Well, this one, here, I'm assuming this is my x-axis right here. So here's my x-axis. It's kind of hard to tell. There's my x-axis, there's my x-axis. So I know this one cannot be it because I have a maximum right before I get to 0. So it needs to be crossing the x-axis right before it gets to 0. So this can't be it. These two do cross the x-axis right before I get to 0. So if I have a maximum, remember maximum, it goes from positive, my derivative goes from positive to negative, or my derivative has to be above the x-axis and then go below the x-axis. So do you see how this one crosses before it gets to 0, but it starts below and goes above, or it goes negative to positive? This one goes from positive to negative, so I know where it goes from positive or above the x-axis to below the x-axis, that's a maximum right there. So I know my answer has to be C. 21. State whether the following statements are true. Explain your reasoning. If f of a is defined, then the limit has to exist. Okay, this is false. And I would just give an example of a drawing as an answer. So they're saying at some point A is defined. So that just means there's a point on the graph. Okay, so there's a point on the graph. The limit of f of a has to exist. Well, that's not true because I could say, okay, there's my a, but when the limit, I might do this, f of a exists because I have a closed point at a, but the limit does not exist because I have this huge graph, because the limit as x approaches a from the left does not equal the limit as x approaches a from the right. Okay, on B, the limit as x approaches infinity equals the limit as x approaches 0 from the right of 1 over x. So I'm not sure. I'm going to graph this. So y equals, I'm going to graph 1 over x. So let's look at this first. The limit as x approaches 0 from the right is positive infinity. Okay, as x approaches infinity of f of x has to equal the limit of x equals 0 of 1 over x. That's not necessarily true because I could have a limit of f of x. This could equal anything. This says this has to equal positive infinity. We don't know what f of x is. It could equal any number. So I don't know why he wants you to put, but I'm going to say that's false. If f of x is continuous at c, then the limit of x as x approaches c exists. That's true because that's the definition of continuity. For something to be continuous, the limit as x approaches c of f of x, this is true, has to equal f of c. And then 22, does the derivative of f of x equals the absolute value of x minus 2 exist at x equals 2? Explain. Here's what that graph looks like. Okay, the rules are the derivative does not exist at any sharp turn, or sometimes they call it a cusp. So this is no, okay, because the derivative from the left, the derivative of x minus 2 where x is less than 2 does not equal, this slope does not equal this slope. The derivative of absolute value of x plus 2 where x is greater than 2. So the main thing you need to remember is if there's a sharp turn in a graph or a cusp looks like this, okay, the derivative does not exist at that point. Good luck on your test.